Thanks very much, Paul. I don't think I'll be revealing any secrets, but I suppose it's a bit unusual becoming after being on the panel. I think a lot of what I'm going to say has been shown before, but we'll see how it goes, and I'll probably skip through a few things. What I plan to do is give you some background in relation to the work at EPA, a bit of the scientific understanding, then the policy responses, and the global goal, which is the 2-degree goal, and what's happening in Paris. So in terms of the background, the Environment Protection Agency has a number of roles in relation to climate change. Number one, it does the inventories, the national greenhouse gas inventories reported to the EU and UN in terms of achieving our targets. We also do projections, as been mentioned earlier, in terms of emissions, with measures, with additional measures. I myself am involved in the research activity, and we focus on providing research support for various activities, including the understanding emissions removals. Then we do the market mechanisms such as emissions trading, and then also we support the engagement with the EU and UN processes. And the Climate Bill will actually give us a new role in terms of hosting the Secretariat for the Climate Change Advisory Council, which the bill hopefully will go through the Senate, the final stages in the very near future. I just wanted to say it's been a very interesting conference, but we're living in a very complex and active planet, and I just wanted to show you a volcano. That's Pinatubo in 1991. When that exploded, it resulted in reduction in the global average temperature about half a degree the next summers. And that's a feature of volcanoes, large volcanoes, which happen every so often, like Krakatoa, Tambora. I used to work on that type of activity. I used to look at particulates in the air, which actually cool the planet. And we produce a lot of particulates. For instance, China, is now producing a lot of particulates, which have a cooling effect. But these are only temporary. The real issue is carbon dioxide. And I just wanted to, I suppose, entertain you a bit by showing you if this works. I was assured it would. Help. Anybody got a mouse? No? I was going to show you a movie of the carbon dioxide history.
The clicker's not working well.
Yeah, it's not. It should.
Do you want to try and?
With that?
No. We have to connect that on home. Let's see if we can get you another. Just give me one. We don't? No. If that's bust, we're bust.
Okay, I was going to show you an interesting movie which show you the carbon dioxide history of the world going back for 800,000 years, and you'd see that we had an extraordinary influence on the CO2 level in the atmosphere. We're way above anything that has been experienced ever in the planet's history. Sorry, not ever, but in the last 800,000 years. So it was quite interesting, and I'm sorry I can't show it to you, but that'll speed us up a bit, I guess. In that context, I just wanted to cite 3 key people: John Tyndall, Charles Keeling, and Sean Toomey.
I'm not sure if this fit for this one.
Don't worry, we'll move on.
Okay.
2 of those are Irish. John Tyndall was from Carlow, and he basically answered the question, why is the Earth so warm? And he did that in the 1850s when he discovered it was gases such as carbon dioxide and water vapour, etc. Charles Keeling, a very stubborn individual who actually set up the first site to monitor CO2 in the atmosphere back in the 1950s. It's thanks to him that we began to understand what was happening due to our use of fossil fuels. And then Sean Toomey, who basically, originally from Cork, who worked a lot in NASA, looked at how those clouds are influenced by pollution and contribute to cooling. So, as people have said, it's all about energy. And that is a sum of our knowledge of what we're doing to our planet in terms of the IPCC. The red bars on top is the warming. The blue bars on the bottom are the cooling. You see at the top it's CO2, methane, N2O. They're contributing, they're heating us up. Some of the aerosols, some of the sulfate aerosols, for instance, particulates are cooling us down. In some, it comes up just about 2.3 watts per meter squared. And you might say that's not a lot, that's a small number. You know, we have 50 watt bulbs in our houses, etc., etc. But if you add it up at a planetary level, it's zettajoules. And hands up, who knows what zeta is? A lot. It's 10 to the 21. So it's so big even the bankers don't use zetas yet. Or even our Web Summit guys aren't using zeta. 10 to the 21, so that's a lot of zeros. And you see all of the energy is going in. It's going into the blue areas, which is the oceans. As somebody said earlier, 90% of the energy is going to the oceans. And that is causing them to expand. Sea level rise is changing the currents. And the oceans are also taking up about 90 or 30% of the carbon dioxide, so they're becoming more acidic as well. Now, usually people go straight into then the global temperature record, but I think the sea level rise record is even more impressive if you look back from 1900 to about 2010. Sea level has risen remarkably, unprecedented changes. There's been reduced ice cover, rainfall patterns, and also flooding. The natural environment has been most impacted so far by climate change, but there are other impacts. The temperature record is a little more noisy, but certainly the trajectory is on the way up. 2014 was a record year. 2015 is likely to break that record. The causes: CO2 and other greenhouse gases. CO2 is the bottom one, it's the brown. The light brown is from fossil energy. The other important source of CO2 is land use. And again, land use change is an important issue and has to be addressed in the Paris Agreement. But certainly we have to grab hold of those fossil emissions. The rate of increase has actually increased in the last decade, regardless of the policy measures. The main sources: 35% from energy, 24% from agriculture, 21% industry, transport, and then the building sector. So that's the global emissions. Obviously Ireland is different, but in Paris we're looking at a global agreement, and certainly we have to address all of those sectors if we are to address climate change. The impacts are evident from the tropics to the poles. They're on all continents and all areas. They affect rich and poor countries. And essentially what climate change is doing is, if there are problems in a country, they are exacerbating those problems. If the country is doing well, is stable, climate change will tend to undermine that stability. So rich and poor countries will be affected. The poor countries and poor populations generally will be affected more because they are more vulnerable. So the oceans, the projections of future climate change suggest the oceans will continue to warm. Sea level rise will continue to increase during the 21st century. It's very likely that we lose more ice cover, and that includes the Arctic sea ice and glaciers. The impacts are multiple. Food and water shortages. Already we see the IPCC fifth assessment report showed that there has been impacts on food production globally. There's going to be increased displacement of people because of climate change. We're going to increase poverty, and coastal flooding will become a big issue. And Ireland itself is vulnerable. We have considerable coastal assets. Most of our cities are on the coast. In fact, all of our cities are on the coast, apart from one, I think. So sea level rise is a key threat. Extreme events, more intense rainfall. The number of storms might decrease, but the intensity of storms could increase. So water management, flooding and land loss will be issues for Ireland. And we have vulnerable infrastructures in our transport and our energy systems. So what is the future? This is from the IPCC as well, as showing, I suppose, two trajectories. One is the red one, which is increasingly warmer world, up to 4 degrees warmer by the end of the century or more. And then the blue one is the sort of world that we're hoping to achieve out of Paris, which is the 2-degree world. And switching from those trajectories is really important if we are to address climate change. And you'll notice that the change doesn't really manifest itself until about halfway to 2050. So a lot of what we have already emitted means we're locked into climate change for the coming decades. It's the future decades that we really have to worry about then after that. I wanted to highlight this one as well. This shows sea level rise. Again, the blue and the red are the trajectories. Ireland, as I said, is vulnerable to sea level rise. What you'll note there is that there is no stabilisation of sea level, even at the end of the century, if we do go to the blue path. Sea level rise will continue to increase well into the next century, regardless of what we do about the global temperature. So this is something that is in Ireland's interest, that we address climate change if we are to protect some of our key assets in terms of our coastal cities. And what we're talking about there is the rate of sea level rise as opposed to the actual maximum sea level rise. So this is the spectrum of pathways that we could, as globally, go on. The red ones are obviously the high emissions pathways. The blue ones are the low emissions pathways. Just pointing out the red ones, we are very much on the red pathway as a business as usual. So current emissions are certainly not sustainable and certainly putting us on a very high risk pathway for the global climate. The blue pathway, just to point out that the dark blue line actually goes through zero somewhere around 2060, 2070. So that means carbon dioxide has to go to zero and then go negative. We need negative CO2 emissions in the second half of this century. How can we do that? Well, we already have negative emissions due to biomass, growing forests, our lands. There's a lot of terrestrial sinks that take up biomass or take up CO2, but we'll have to enhance that perhaps by using biomass for energy with carbon capture and storage if we want to do negative emissions at scale. So in terms of the policy response, basically in 1992 at the Rio Art Summit, we established the UN Framework Convention on Climate Change. The objective of that convention is to stabilise atmospheric greenhouse gas concentrations at a level that would prevent dangerous anthropogenic interference with the climate system. That's usually shortened to dangerous climate change. So since 1992, we've had a global agreement to prevent dangerous climate change. Key meetings of the convention, Berlin was the first one. The Berlin mandate came from that. The chair of that particular meeting was a certain Angela Merkel, who has since gone on to a higher political office in Germany. Kyoto obviously gave us the Kyoto Protocol. Copenhagen, Eamon described it earlier as a disaster. It did have some outputs which were significant, including the Accords, which first time incorporated this 2-degree goal. And that goal is to keep the global temperature below 2 degrees centigrade, keep the increase in global temperature below 2 degrees centigrade. That was more substantially agreed the following year in Cancun, as was endorsed fully by the UNFCCC as a global goal. However, even in Copenhagen, a number of parties said it was not adequate. We should have a global goal of 1.5 degrees centigrade, and that's been an issue that has been discussed ever since under the UNFCCC as the adequacy of the long-term global goal. And Paris, we need a new agreement if we are to turn this trajectory around in terms of our emissions. So, is 2 degrees adequate? As I said, there's been an ongoing discussion. Those bars there are from the 5th Assessment Report, and they look at what's euphemistically called as reasons for concern, because IPCC cannot be policy prescriptive. And you will see that those bars get redder as you get hotter. So the reasons for concern get more and more problematic as the temperature increases. The grey line is about where we are now. So we're already into unique species being threatened. We are losing certain species due to climate change. The extreme weather events are hitting home. But the big ones, the large-scale impacts, we probably will escape the worst of those if we do keep the temperature below 2 degrees. But it's not as clear-cut as it used to be. The more science we learn, the less certain that we are that 2 degrees will protect us from the major impacts. But one of the key things about the 2-degree goal is that it gives us a clear signal as to what the emissions trajectory should be if we are to achieve that. And if we want to make it lower, say 1.5 degrees, we just look at the trajectory for 2 degrees and we do it more rapidly. So what do we need to do? To have a good chance, a 66% chance of staying below 2 degrees, at the 2-degree increase, we need to reduce emissions by between 40 and 70% relative to 2010 levels by 2050. That's a finding from the IPCC 5th assessment report. We need to have all greenhouse gases near or below zero by 2100, and carbon dioxide emissions need to be reduced to net zero somewhere in the period by 2055 to 2070. And then that will be followed by negative emissions. We need negative emissions because some emissions of some greenhouse gases cannot be reduced to zero. For instance, methane and N2O. There's, food production systems, not necessarily cattle, but rice, whatever, means that we will have residual emissions of those gases. So we need negative emissions of CO2 to offset those. In terms of negative emissions, as I said, these are also high risk. The more we rely on negative emissions, the greater the risk becomes. So that's why the EU position is that we should reduce emissions by at least 60% by 2050 relative to 2010 levels, because negative emissions, as I say, now are envisaged coming from biomass for energy with carbon capture and storage, and that puts demand on land, and land is obviously useful for food production, which is also essential. So we're in a difficult situation. In terms of the cost of this, the costs are not enormous. We're going to have to invest in a lot of infrastructure, a lot of new buildings. What we see is deferred growth of about 0.6%, reference to business as usual of 1.6 to 3%, and that's globally. And usually this analysis doesn't take account of the co-benefits, and the co-benefits are massive in terms of air quality, human health, energy security. So the road to Paris, I suppose the good news on the road to Paris is we have a process, or we established a process about a year ago, that countries would come up with their individual national contributions. And so far, 154 countries at least have come up with their individual national contributions. And this covers about 90% of global emissions. So rather than the Kyoto Protocol, which is covering, I think, less than 12% of global emissions at this point, we have now all of these parties saying we are going to do something about our emissions. I suppose the bad news is they don't sum up to a 2C world as yet. It brings us below the 4-degree world. We're bending the curve in the right direction. We're not bending it enough. And also, it's very difficult to do the assessment because a lot of these contributions are different bases. Some of them will have intensity targets, they'll have different reference years, they don't include all sectors. The EU certainly does include all sectors. That's the 40% reduction that I spoke about earlier. So much more is needed by everybody. And that, I suppose, since there's a lot of business people here, that will include the business community. I suppose the opportunity is that the Paris Agreement will create the mechanism to increase global ambition, and doing this will make us wealthier, it will make us healthier, and that's it. Thank you.